Okay, so we started looking at the AWS Lambda service the last day. So we're going through these slides here, and everybody should have at least started this lab this week as well. So what Lambda is AWS's main, there are others, but it's its main serverless compute service. That's how we describe it. And it essentially allows us to deploy something as small as a function um, and trigger the execution. We talk about triggering the execution of that function by various means. The only way we've triggered it so far is by invoking it from the command line using the AWS CLI. And we looked at the what I'm calling the anatomy of a Lambda function, which has sort of the main body is what we refer to as the handler. But outside of the handler, you can have preceding it anyway, you can have initialization code. You can also have private functions if you want to, but the assumption is that these private functions are invoked from the within the handler, so they are effectively part of the handler. And I also mentioned, and we'll see maybe later on as well, is that so sorry, so when we trigger when we want a Lambda to be executed, we know that what the Lambda service does is it creates what I'm calling a micro VM. That's what the documentation kind of calls it as well. Creates a micro VM, uh, sets up that micro VM to contain the environment that's required by the Lambda. In our case, that would be some sort of Linux base, an installation of the Node.js platform. And then having done that, it loads our Lambda function into that micro VM. It then executes the initialization code first, and then executes the body uh, of the handler. Sorry. Uh, that's fine. If another triggering of the Lambda happens fairly soon after that, and there's no way of quantifying what fairly soon is, but let's say it's pretty well immediately after that, given that it now has that micro VM ready to go, so to speak, it doesn't have to execute the initialization code this time. It will only execute the body of the handler. So we kind of had all of that the last day. And I demoed and then bringing the CDK framework into this. How do we include a Lambda function in our CDK stack? Um, we looked at that the last day as well, and we triggered the Lambda from the command line. So that's kind of where we left off. Yeah, so I did this kind of demo with you. Um, by Lambda integration, what I mean here is what services can trigger a Lambda. And pretty well, most of them or an awful lot of them can trigger your Lambda function. I'm only just showing some of them here, really. Now, uh, there are three models of integration, and these are really, you don't have a choice as to which model you pick. The model depends on the source event, the source service, the source service that wants to trigger the Lambda. So if you want, let's say S3, that service to trigger the execution of your Lambda function, then S3 uses one of these three models. Okay, you don't have a choice to pick one of them. So I'm going to just briefly talk about each of these models, and we will see each one of them in action. You know, we'll concentrate on synchronous initially, but we'll see the asynchronous and polling based ones further down the line. The synchronous one is the easiest one to understand. With the synchronous integration model, uh, essentially your client waits for the Lambda to respond back to it. First of all, I'm telling you here which of the services or what are the different ways you can trigger a Lambda where the integration model is synchronous. Well, as we saw last time, you could use the CLI. When you do that, then you are, and that's kind of illustrated here. If we imagine our CLI is here, uh, when we invoke the CLI, now we always know, right? I'm sort of showing it here as if my CLI is invoking the Lambda directly, but of course we know that that's never the case. The Lambda service is always here, right? Uh, so it's really your CLI is talking to the Lambda service, and the Lambda service then takes care of triggering or executing your Lambda function, loading up the micro VM, etc., etc. The Lambda executes and it returns a result or a response, and that response is sent back to the CLI. But the CLI is waiting for the response to come back. Hence, we say that this communication is synchronous. If you're using the SDK, so if I actually wrote an application using the AWS Lambda's SDK, and maybe that application is just running on it's a desktop application, or it could be a mobile app application, it doesn't really matter. It's running outside of the cloud anyway. And I make an SDK call to my Lambda function. It's the same kind of synchronous mode of communication. So my desktop application, if that's what it is going to wait for the response to come back. API Gateway also uses this model. API Gateways, we'll see that service later on. It's a service that we use when we want to develop a RESTful web API. And this API gateway service is kind of the front end of our RESTful web API. And I'm kind of showing it down here. This is kind of the logo for API gateway. So the typical kind of scenario here might be, let's say I've got a React app running inside in my browser on my desktop. That's sending requests to API gateway, and API gateway is, again, the Lambda service is in here. API gateway is asking the Lambda service to execute a particular Lambda function. But again, the request and response, my client over here is waiting for the response to come back from the Lambda function. You could actually have a load balancer. You could have a load balancer in here. We're not going to do that because we're going fully serverless, so to speak. API Gateway is a serverless service as well, um, but load balancers are not. But also, which was a kind of a more recent thing that the AWS people, designers introduced, was what are called function URLs. So you can actually get the Lambda service to generate a URL for a Lambda function. And then you can just use that URL in whatever way you want to. You can put it straight into a browser, or you can make a HTTP call from, a web app or whatever. Yeah. But again, it's the same kind of synchronous execution flow that's going on there. So our client, these are all our clients over here. Our client is always waiting for the response to come back. That's how it's characterized. Also, um, I'm seeing here, right, that the client should, you don't have to, but the client should deal with error scenarios as well. And how you deal with them depends on the nature of the client over here. You may want the client to retry a couple of times to execute the Lambda function, because the Lambda function may not execute for any number of reasons, networking issues, availability issues. The Lambda service is too busy, and we'll see what we mean by that later on. So maybe your client, rather than just giving up after the first attempt, should retry how many times depends on you really. Exponential backoff is typically when we do program our client to retry a number of times. The typical way you would do it is to apply this exponential backoff algorithm. So you would wait for a certain period of time, let's say 2 seconds, try again. If it fails, then double the wait time to 4 seconds, try again. If that fails, double it again. Usually you'd only try 3 or 4 times, but you keep doubling the delay time in the hope that you will eventually get a valid response back. But as I said, it's up to the client to program that, or it's up to you, I suppose, to program that into the client. The Lambda service doesn't do it for you, although it does later on when we look at some of the other models. Anyway, that's synchronous. Um, yeah, well, what I was just going to do then is just illustrate this function URLs. It's not terribly exciting, but if we go back to our code and sorry, can I just check Slack for 1 second? Is there somebody sending me a message? I don't see anything. No, okay. This was the stack that we had at the end of last week's lecture. So here's our stack file. Yeah. And here's our Lambda function. And I talked through that the last day. Well, here uh, I'm generating using the CDK code, I'm generating a URL, or sorry, I'm asking the Lambda service to generate a URL for my Lambda function. And again, well, sorry, in this case, what you pass to it is you have to tell it what kind of authentication you want. Now I've selected none just for simplicity, but there are two options available to you. You can say you don't want any authentication, so effectively it's a public URL, or the other option is to use AWS's IAM, which is, if you might remember, AWS SIG v4. That's the kind of their custom authentication model. But for simplicity, for now anyway, I'll show you how to do this in the lab actually. But I've picked none, okay? And you also have to specify your CORS configuration. You can read up on CORS again because you've covered that already in the web app dev module. So I'm effectively saying anybody can use this URL. And that's it really. Once I've done that, now I'm just outputting the URL here for convenience. But when I do my CDK deploy, which I've done already, and that's all that's in my stack. When I've done my CDK deploy, and if I switch over uh, my AWS account, functions, and it's this one here. And if we look at the configuration, which I have open already, and if we scroll down here on the left, we will see eventually here function URL. And here's the URL that it generated. And if I just navigate to that, okay, that's the response back from my Lambda function, which we had the last day. But just to remind ourselves, here's my Lambda function. and its response was that message that we've just seen. And that's what we got back. Okay. So that's obviously neater than invoking from the CLI. So given that we now have URL, we can invoke it from our own code running on our own desktop if we want to. Okay, that's straight. Sorry, yeah. If you pick the AWS IAM authentication mode, then you can't invoke that from the browser like I did there, because what you have to do is configure the authentication. Now, the easiest way to do that, and I explained that in the lab, but just to quickly show you, I'm not going to redeploy it now again, but if you go into Postman is what I use. You can use some other one if you want to, but I find Postman is easy. So I've created a Postman collection, as it's called here. I've created a number of collections, which I will work my way through this module, but I have a collection just dealing with function demos. So this is my collection. This is switching over to Postman now, nothing to do with AWS, obviously. But if you remember, if you played it all with Postman, when you create a collection, you can define variables at the collection level. And I have defined two variables, one called URL, and it's in there. I would put the URL that was generated by the Lambda service for me for my function. I'm also defining two other variables, access key and secret access key. These are the keys that you would have generated when you created the IAM user. If you remember back when you created the IAM user, uh, you had to generate a set of keys, AWS keys, one called access key, one called secret access key, and you downloaded those and you configured your AWS CLI, if you remember, with these two keys. Well, we're going to need these keys now actually when we're sending a request to our Lambda function using the URL, given that we've configured the Lambda URL to use AWS IAM authentication. So that's okay. There are just three variables. Be very careful when you're pasting the values into these variables. Okay, you can't, if you have a space at the end of them, or if you've got the return key, the return character at the end of them, then that's going to mess things up. So just be careful with those two. But in Postman terms, so I've created a collection. Oh, sorry, before I move away from that, sorry. The other thing you can do at the collection level, we're still at the collection level here, is define what authentication you're going to be using. And so if I go into that, uh, Postman supports a number of authentication options, which are listed here. And if I just expand that, so these are all the options. Again, you've used probably JWT tokens last year, but one of the options is AWS signature. And if you select that option, then you have to enter various things here on the right. You have to enter the access key. And I've set the access key to refer to one of my variables that I've defined. I could put the access key in here directly, but because I've defined the access key as a variable, then I can just refer to the variable. And that's what this syntax is here, this double curly brace, close double curly brace, and just put in the key name. Like if I just actually got rid of that, once you start typing, you may know all of this already now, but anyway, once you start typing the double curly brace, then it will prompt you with the various variables that you've defined, because it knows you're trying to refer to a variable here. So I'm just selecting that one. Similarly, you have to specify the secret access key, As well, you have to set the region that the Lambda uh, is located in, so to speak. And finally, you have to tell Postman that you're using the Lambda service. So I guess Postman, it uses all of this information to kind of sign the request that you're sending to the Lambda service effectively, right? We don't have to look at the detail of that signing, but that's what Postman is doing for you. And so having done all of that, I then go in and create a request for myself. Let's say it's this one here. It's a GET request, and I'm referring to the URL variable that I've defined. And I also have to set the authentication, and I've set the authentication to refer to parent. Again, I could have done all the authentication here because once I expand this drop-down menu, like one of the options is AWS signature. So I could have put all that stuff that I was talking about which I've defined at the collection level. I could have put it at the request level. But if there were a number of requests that I wanted to create here that were all using uh, authentication, then rather than defining it for each of them, defining it at the collection level is just more convenient. As I've said a couple of times already, you'll do this in the lab anyway. So if you have any problems, you can talk to me in terms of setting it up, because there is a bit of setting up of um, that kind of test case. Any questions, I wonder? No, it's not until you actually do it, I guess, that you may have questions. Right. That was just another simple illustration of deploying a Lambda. In this case, adding a custom URL to that Lambda function. And that's the only illustration of the synchronous mode of integration that we will look at for now. Later on, we will see, if I go back to here, later on, we will see when we're using API Gateway. Well, I mean, it's just using the synchronous integration mode. We don't have to delve into it. We understand the basics of it. Um, that's fine. Okay, I'm going to move on. The asynchronous integration mode, that's used by these services. So, for example, if you want to trigger the execution of a Lambda function when something changes in an S3 bucket, and you can define what type of change, whether it be a new upload or an update to an existing object in an S3 bucket, or when an object is deleted from an S3 bucket, um, and you want to trigger a Lambda function when some or all of those kind of events occur in the S3 bucket, then you can configure that, okay? And we'll see that much later on. Kind of showing an illustration of it down here. So, okay, our client is really way over here. And again, a client could be a web app, or it could be a desktop app or a mobile app. And or it could even be the command line. It's performing the update, or it's performing the kind of state change to my S3 bucket. And using my CDK code, which you'll see later on, I will be able to configure the fact that when that state changes in the S3 bucket, I want to trigger this Lambda execution over here. Now, what actually happens is, so the client performs let's say it's an upload of an object to the bucket. Um, the S3 service then will tell the Lambda service of the upload. The Lambda service kind of will queue this changes, because there could be a rapid number of changes happening to the bucket. It will queue those changes internally, and the Lambda service takes care of invoking your Lambda function, and it will pass some or all of the entries in this queue. So the key point is that the Lambda service is actually invoking the Lambda function. Meanwhile, back here, once the client has uploaded the object to the S3 bucket, and S3 has responded saying, yeah, I got that. Now the client is out of the picture. So it won't know anything about what happened over here. That's obviously an issue you may have to program into your overall application. So maybe the Lambda sends an email back to the user or whatever, or some sort of, or an SMS message or something like that. We don't care about that. So in a sense, like why we're saying it's asynchronous is because there is no waiting around for the client by the client until the Lambda function has processed the event being an object was uploaded to the bucket. Also, it's the Lambda service that actually invokes the Lambda function and it passes it either all of the contents of this or some of it. If the Lambda happens to throw an exception, then the Lambda service will try again. And I think it tries 3 times and it actually follows that exponential backoff approach towards the retries. And then eventually it gives up, I think. So I'm saying here that the Lambda service retries on error. So whenever an error occurs in the actual Lambda function execution, in other words, when it throws an exception, it'll retry 3 times. What else am I saying? Okay, that's all right. Oh yeah, I'm saying that it's just something you have to be aware of, that the function should be idempotent. Idempotency means that, supposing my Lambda function is processing one of the events, that happened over here, and halfway through the processing, it throws an exception, but it has done some of the processing of that event, which may be, write something to a database. But it throws an exception somewhere later on in the execution, which means that the Lambda function is going to ask it to try it again. And it's going to start processing the same event all over again. So does that mean now it's going to make 2 changes to my database? So you have to be aware of that, and you have to make sure that however you program the Lambda, you're not falling into that trap of reflecting the event more than once. Hence, it should be idempotent. I'm just stating that, right? We're not going to necessarily have time to get into how do we handle idempotency. Just don't have time, but just something to be aware of. And I'm sure you've heard of idempotency before. And oh yeah, I've made this point here. Now, obviously, yeah, well, okay, I'm not going to say anything else complicated. Other services follow this asynchronous mode as well. SNS does, which we will see later on. We'll see the S3 example as well. SNS, you can even have CloudWatch triggering a Lambda. But for all of these services, when they want to trigger a Lambda, they're all following this asynchronous model, right? You don't have any choice in that matter. The third model, so there's 3 models: the synchronous model, the asynchronous model. The third model is kind of got a funny name, event source mapping. Think more, this is kind of a better name, pole-based integration. And really, the services that use that is, for example, this is the one that we can relate to, or we could relate to slightly more than the other ones. DynamoDB streams. The idea here, the image kind of shows you. The idea here is, so some client, again, desktop application or mobile app, it requests, sorry, it makes a request that causes some change of state to happen in my DynamoDB database. That's what this is representing. And I want the Lambda function down here to process the state changes that are happening in my database. But the way this works is the Lambda service periodically polls the database, asking it, have any changes happened to your state since I last polled you? And it'll get a response back. And again, it does a kind of a queuing of those state changes. and it calls the Lambda function again. It invokes the Lambda function. But the key characteristic here is that the Lambda function, the Lambda service is talking to the other service, asking it whether any state changes. Whereas if I go back to the previous one, here, sorry, here the source is telling the Lambda service to call it. Like it's telling the Lambda service the event has occurred. Whereas in the other one, the Lambda service is asking the source, has any event occurred? Right.
Jim, I have a question about this one.
Yeah.
So, you know the way this is constantly polling it and the service needs to be on, does that rack up extra costs for passively just existing?
On the Lambda function side,
Yes.
yeah. Well, you're only charged for how for the execution of the Lambda function. So I suppose the answer to your question is you're not charged. Although you're not charged for the polling as such. You're only charged for the execution of the Lambda. So if it's polling and there's nothing there, you're not charged for that. Although
Yeah,
I'd
that's
have to
perfect.
read the detail on that though, but to be absolutely certain about it. But I mean, the upfront, what we're always told is you're in charge per execution of your Lambda function. So I'm kind of assuming that you're not charged for the polling. Yeah, that's probably that's an honest answer, uh, but it's uh, it's rational enough, I think.
Yeah, that's perfect. Thank you.
Yeah. Um, you can probably, there are so many options when you're configuring all of these things. You may well have the option to control, in fact, I'm certain you do, to control the frequency of the polling. So if you know that the nature of the data in here is slow moving, then you can control that. Um, okay. SQS, which is another service that we look at, follows this same polling model. So the Lambda service, I've said that already. Lambda service invokes, I've said that already. Um, like always, every AWS service, not just the serverless ones, but every service has an API interface to it, a web API interface to it. That's how we get services to talk to one another. Uh, and every service, as well as having a web API interface, there is an SDK provided by the AWS people to facilitate using the web API. Otherwise, if there wasn't an SDK, we would have to make raw HTTP calls. So that applies to the Lambda service as well. It has a web API and there is a Lambda SDK in various languages. Okay, and you would have used Boto 3, which is the Python one last year. And so, like, as well as I can write code, we could write code and run that code from our desktop, and by using the Lambda SDK, we could communicate with the Lambda service. Yeah. But all of the other services that want to trigger a Lambda function, we've been talking about them in the last few slides, they are actually using the SDK internally as well. That's kind of just by the way. Uh, that's okay. And so the payload, as it's called, the event that's being passed to the Lambda service, which eventually our Lambda function is going to process. Because if you remember the signature of a Lambda function, it takes two arguments, although we're really only interested in the first argument, which is called the event. Um, the structure of the payload part of the event can be anything at all, can be any type of object structure. It doesn't have to conform to a particular shape or type as such. That's the payload part of it now. The event itself does follow a predefined structure, but the payload part of it can be any type of object. So up to now, I've been talking about who can trigger a Lambda or what service can trigger a Lambda. That's what we've been talking about over the last few slides. The other side of the coin is what services can our Lambda function talk to? And it can talk to any Lambda service. Sorry, our Lambda function can talk to any other service, but it's controlled by what's called the Lambda function's execution role, which is an IAM role. Okay, so you associate an IAM role with your Lambda function, and within that IAM role, you define the IAM policies, and they control what other services our Lambda function can talk to. And that came up in our discussion last week, I think, in relation to a Lambda talking to a DynamoDB database. So that's this notion of an execution role. And there are a number of kind of predefined IAM, what I call managed IAM policies, specifically for Lambda function execution rules. This one here, this policy called AWS Lambda Basic Execution. Every Lambda function is automatically assigned that uh, policy, or that policy is assigned to its execution role. And what that policy allows the Lambda to do is essentially talk to CloudWatch, because it's assumed that every Lambda will want to execute console logs or whatever the equivalent is in the language that it's implemented in. And I can kind of prove that to you if we so here's the Lambda function that we've been looking at. And in the configuration section as well, there is a permissions tab on the left. And here we go, execution role. This execution role was created. There's a guideline that you should have an execution role per Lambda function. Don't go sharing execution roles, because that can cause complications later on, because if you want to add some policies to the execution role, you may find yourself end up adding extra privileges to a Lambda function that you didn't intend. So kind of a one-to-one relationship is what's recommended. But this IAM role was automatically created by the CDK framework for my Lambda function. Even though there's nothing in my CDK stack code to do that, it just happens automatically. And if I look at that IAM role, so we've moved over now to the IAM service, as you can see here. And if we look at the permissions, there is a policy, and there's the policy, AWS Lambda Basic Execution. And if we drill down into that, so this is an IAM policy. And if we look at the where is it again? This stuff always kind of throws me because I don't look at it often enough. Yeah, you can see it's talking about CloudWatch logs here. I wanted to see the JSON form of it. Why can't I? Thought I should be able to see the JSON form of the policy. Am I missing something? Sorry, just give me 1 second. Okay, oh, there, sorry. Oh, there it is there. Again, this should trigger some memories for you from that module in third year. So this is an IAM policy, and it talks about uh, essentially allowing my Lambda function to access this part of CloudWatch logs web API. Yeah. So anyway, that's this idea of an execution role that you attach to a Lambda function. And we'll find ourselves going back to look at that later on when our Lambda function starts talking to other services. Right now, it's only talking to CloudWatch logs, which is kind of a default. I've mentioned that already. There's also something called the resource-based policy, and the resource-based policy controls who or what can trigger your Lambda. So it's kind of the other end of the stick, if you like. So the execution rule determines what your Lambda can do. The resource-based policy determines who can actually trigger your Lambda. And again, if we go back to, um, well, before I do that, so typically you either want to allow what's called an IAM principal, which is either a user or some other service. You want to allow either a user or some other service to have the ability to trigger your Lambda. Uh, Now, there's two ways that you can achieve that. I'm saying here either the IAM principal is granted the permissions explicitly, so it's kind of on the source side. You've configured the source so that they can trigger your Lambda function, or the function's resource-based policy states that they can trigger your Lambda function. The S3 service. So yeah. So if I go back to again, kind of, but we haven't looked at anything significant so far. If I go back to the Lambda that we have, um, and if we scroll down here, you can see here's where the resource-based policy. And if we drill into this, essentially what this is saying is that, there's a function URL that will allow that's allowed on for this Lambda. So in other words, it can be triggered by using a function URL. It's roughly what that policy is enabling. Okay. We'll certainly look at execution role a little bit more later on. What's next? Concurrency and throttling. I did mention this the last ATE as well. So in general, if you've got this Lambda and you've got some sort of event source, it doesn't really matter what the event source is. But let's supposing there is a high volume of concurrent events targeting your Lambda, then what the Lambda service will do is it won't just feed those events one by one to your micro VM. It will actually create parallel instances of the micro VM and load balance the high volume events between the various micro VMs. So this is kind of what we're trying to illustrate here. We've got lots of micro VMs in parallel, all executing the same Lambda function. And that has happened because of the high volume of source events that are concurrently happening. Now, but there is a limit to that. Uh, and again, if I go back to maybe jumping around a bit too much here now, but if I go back to the if I go back to the dashboard, you see where it's saying my full, what is it calling it? Full for account concurrency. What this is saying is that I can, in my account, in this AWS account, there can be no more than 1,000 micro VMs running. Now, those micro VMs don't have to be all running the same Lambda, but I'm not allowed to have more than, sorry, not 1,000, not 100, 1,000 micro VMs. And that's kind of the default upper limit that's assigned to every AWS account. You can ask the AWS people to increase that, but of course, there's a charge on that. So there is an upper limit on how many micro VMs you can have executing attached to your AWS account concurrently. Yeah. And as I said, they don't have to all be executing the same function. So uh, that's fine. And what else am I saying here? Oh yeah, you can set a reserve concurrency at the function level. So in my CDK stack, I could indicate as part of the Lambda uh, configuration, I could set a limit to say, let's say there should be no more than 10 concurrent instances, uh, uh, 10 concurrent micro VMs running for this particular Lambda function at any time, no more than 10. Now, what that means though is that if there is 20 or 30 concurrent events happening, then let's say it's 20, then 10 of those events will receive a throttling response, error response back to whoever the source of the event is, whoever the trigger was. So let's assuming it was just I have a URL associated with my function and I'm triggering it from Postman. And let's supposing I'm able to generate 20 concurrent invocations of that URL, and I've set the reserve concurrency of my Lambda function to be 10, then, okay, the first 10 will get through. It'll create 10 micro VMs, but the Lambda service is going to return a throttling error for the other 10 requests. And a throttling error in HTTP terms is a, what do I call it, a 429 uh, status error response. Uh, That's fine for the asynchronous model of integration. For the synchronous model of integration. For the asynchronous model of integration, what actually happens is it's it sends an error message into a separate kind of queue called a dead letter queue, which is an SQS queue, and then you could either be manually checking that queue, or you could have a Lambda actually feeding off of that queue to process those throttling errors, whatever the nature of the processing might be. Uh, so this idea of this reserve concurrency is just something to be aware of that you can set at a Lambda level. Now, if you don't set it though, then something like this might happen. Let's supposing I've got three applications in my AWS account. And the specifics aren't that important, but let's say that one application has an application load balancer and that's hooked up to a Lambda. Of course, always the Lambda service is in here between them. But this a application load balancer is hooked up to a Lambda. It might be hooked up to other things as well, but we're only interested in this side of it. And well, okay, I've got another application that has an API gateway and it's also hooked up to a Lambda. And I've got another application that has a Lambda over here and it has a URL associated with it. And I've got some sort of client-side application that can trigger that Lambda. So there are three separate applications. But let's supposing at a particular point in time, there is a very high volume of interaction, user interaction with my application load balancer, such that it causes the Lambda service to create 1,000 concurrent micro VMs processing all of the events that are happening. And I haven't set any reserved concurrency on this one. So it's going to consume my AWS account's upper limit. That now means, of course, that if there's a user trying to trigger this Lambda over here, then they're going to get a throttling error response. And similarly here, you're going to get a throttling response. That's probably not a good idea. It's probably better to try and at least have some processing done by all of the applications. So essentially, what I'm trying to get across here, I'm making the argument for it's a good idea to set a reserve concurrency on all of your lambdas, so that this kind of scenario doesn't arise.
Does that mean we have to like take away from the top layer
It
to
does,
so
yeah,
leave?
yeah, yeah.
Okay.
So that's kind of part of the whole kind of tuning thing, I suppose. Tuning of your applications, knowing what the nature of the application is, the kind of usage patterns, and all of that stuff, which we won't be going into, but it does, of course. Or you may, yeah, it may be that really the functionality that's being performed by this Lambda, maybe it shouldn't be in a Lambda at all. Maybe it should be something working in a uh, on an EC2 instance or working inside a container. Maybe it's just not suitable for uh, Lambda deployment. These are all the kind of hard decisions that have to be made. Okay. I think this is the last one that we look at. Yeah. So we have something called cold starts. And if I go if I go way back to if I go way back to here. So I talked about when a Lambda function is triggered, uh, the Lambda service configures a micro VM, loads a function. It executes the initialization code first and then executes the handler itself. Now, we refer to that uh, as a cold start of our micro VM. A cold start because it actually had to execute the initialization code before it executed the handler. If there is a subsequent event uh, and our micro VM is still available to us, then as I said, it doesn't execute the initialization code, it only executes the handler. That second execution is referred to as a warm start. And clearly it's going to be quicker than the cold start because typically the kind of code that you put in initialization code um, or in the initialization section typically involves, establishing connections with other services and waiting for those services to set up the connection and all that. So it can be quite slow. So cold starts are typically, from a latency point of view, they have greater latency than a warm start execution. And that might be significant. Yeah? And so to go back to the slide that we're on, what you can do if the cold start is significantly longer or takes longer than a warm start, what you can do is declare what's called a provisioned concurrency for your Lambda function. And essentially what that does is it causes the Lambda service to kind of pre-set up some micro VMs ready for use. And you can control all of that as well at the Lambda function configuration level within your CDK stack. We won't be doing it, but I'm just making you aware of this notion of provision concurrency as opposed to, so we've got two types of concurrency settings that we can configure for our Lambda function: reserved concurrency and provision concurrency, and just be clear on the differences between them. Um, okay, so the bullet points covers everything that I've mentioned already. Now that's all we're going to do with Lambda really, although we're going to be using Lambdas right throughout the rest of this module, but we have all of the essentials that we need in order to use our Lambdas for different kind of use cases, which means I'm going to move on to a different service and a different nature of service. There's a service called DynamoDB, and it is a serverless database service where the type of database is referred to as a NoSQL uh, database schema or database um, structure, let's say. And I'm assuming people are already familiar with NoSQL. Uh, Although, yeah, like initially it's okay to say that DynamoDB is a NoSQL database system. But if you started drilling into it a little bit more, and again, we won't get time to do that, you'll find that it has some aspects to it that are quite different from your more conventional NoSQL databases. I guess the one that you would be familiar with would be MongoDB, which is kind of a classic NoSQL database. And initially, MongoDB and DynamoDB, they look kind of the same. But once you start digging a little bit deeper into them, you'll find that there are characteristics of there are features in DynamoDB that you just don't get with Mongo or pretty well most of the other NoSQL databases. But for now, we're just going to say it's a NoSQL database type. It's what's we often refer to as fully managed. Fully managed is really a byword for serverless. So you're not involved in setting up your database server and configuring it and all of that. That's the whole nature of serverless, of course, as we've said, and DynamoDB falls into that. So all we do is just say we configure DynamoDB, or we ask the DynamoDB service to create a table. And obviously there's some sort of server underneath all of that, but we don't worry about it. So it's fully managed, highly available. What actually happens behind the scenes is that the DynamoDB service makes replica copies of your data across three AZ zones. You kind of get that for free. And therefore, that's where the availability comes in. So if one AZ zone goes down, then your data is still accessible from the other AZ zones. And that replication is managed and taken care of for you by the DynamoDB service. Again, you're removed from all of that server level stuff. Schemaless means in this case you could have two, let's use the relational terminology. You could have two records in a table and they could have completely different structures. That's allowed in MongoDB as well, actually, but that's what we mean by schemaless. Uh, well, I'm saying here there's no support for table joins. You know, in relational databases, you have this idea of referential integrity. If you remember, the idea there is that in one table you could have a foreign key field, which is referring to the primary key of entry in another table. Okay, so the two tables are joined by that foreign key relationship, and there is referential integrity between the two tables. You won't be allowed to have a foreign key field value that doesn't have a matching primary key in the other table. Okay, but you get none of that in DynamoDB. Like referential integrity is great, but it does slow up the processing of database operations. Yeah, which is really why NoSQL came about at all, right? To um, to get rid of that. Now, the consequence though is you may still want to have show sort of relationships between different parts of your data set, but you think about denormalization if you want to achieve that. And I'm assuming people are kind of familiar with denormalization from somewhere else. Integrated. Oh yeah. Okay. Well, IAM kind of appears everywhere across all of the other services. So the same applies here. IAM is really what controls who can change a database table and all of that, who can read from it, who can query it, etc. And we'll see that later on. Supports event-driven applications. We actually came across that earlier on when I was talking about um, making a change to your database state and that triggering the execution of a Lambda function. That's an example of event-driven architecture. Uh, so that's fine. Now, okay, every kind of technology has its own language. So in the world of DynamoDB, we talk about tables. Well, we know what a table is from the relational world, so there's nothing new there. That's okay. However, a table's entries are referred to as items. Okay, that's what we would be calling records in relational world, but for some reason they call them items. An item has attributes. That would be kind of columns in your relational world. Schema lists I've kind of already mentioned too, which means that the attributes can be different. Well, attributes schema list has two parts to it really. It means that you can add a new item to a table where that item has attributes that no other item in the table has. And even if other items in the table had the same attribute, DynamoDB doesn't necessarily make that relationship. You have the notion of a primary key for an item. Well, we know what primary key means, and it means the same in the DynamoDB world. Okay, it uniquely identifies each item in the table, and you have to have every table you have to declare what the primary key attribute is for that table. That's really all you need to do when you create a table. You do need to tell it what is the primary key attribute. Other than that, you don't tell it about the rest of the attributes. Maximum size of an item is 400 kilobytes. Okay, so there is an upper limit. Okay, that's the size of an item. Okay, so I guess if your items need to be bigger than that, you need to rethink your table design. DynamoDB has its own native kind of data types, which are these here. Yeah, nothing unusual there. Just to talk a little bit about the primary key. So there are two options available to you, we're told here. One is when your primary key is what's called a simple primary key. Simple simply means that it consists of just one attribute. Now, when that is the case, the primary key also plays the role of what we call a partition key, and I'll explain what that means in a moment. But for now, we're just going to say that the primary key, when it's a single item, when it's a single attribute, sorry, then clearly the values uh, for the primary key, what I'm talking about here, they should be they should uniquely identify each item. That's fine, and the range of values of your primary key slash partition key, the range of values should be diverse. Broad range of values possible. And that would make sense for primary key as well in our understanding of what primary key means from the relational database world. But it turns out now that this partition key plays a role in how your data, in where your data is actually stored. Okay, the example makes sense, and that would make sense in the relational world or the non-relational world. So let's say we've got a users table, and the user ID is a classic example of the simple type of primary key. The other option is where your primary key is composed of two attributes. One of the attributes has to play the role of the partition key. I still have to explain what that role is, but it has to play the same role as the partition key. The second attribute is what we refer to as the sort key or the range key. And this combination have to uniquely identify an item within a table. So that unique identifier characteristic applies to both scenarios. Combination is unique, that's fine. This results in item. Oh yeah. So what it means is, so if you've got a table that has a composite primary key, then you will have a number of items that have the same partition key value, but a different sort key value. And so we often refer to that set of items that have the same partition key and a different sort key. We often refer to it as an item collection, and the documentation refers to them as an item collection. Uh, okay, so they're grouped. And also what you'll be guaranteed is if you've got this composition key scenario, you'll be guaranteed that the items that have the same partition key and a different sort key, those items will actually be physically beside each other in the table. They're kind of grouped by partition key. DynamoDB sort of takes care of that for you. And in addition, the items will be you can retrieve, you can ask DynamoDB, when you ask DynamoDB to retrieve that collection of items, it will give them back to you in the order of the sort key, which is why it's called, referred to as the sort key. But the sort key is just another attribute, right? It's another attribute that occurs naturally in whatever the domain of the data is. And similarly for the partition key, it's some attribute that occurs naturally in the domain. An example probably makes things clearer if they're hopefully clear already. Supposing I've got an application that's some sort of gaming application where you've got lots of users, hundreds or thousands of users, and you've got games that they can play. Now, the number of games would obviously be a lot smaller. Okay, so let's say there's 100 different types of games, but we've got thousands and thousands, hundreds of thousands of users. Well, for that kind of scenario, for storing, and we want to have a table that stores, let's say, the score that each user has achieved in each game, and when did they last play the game, and some other uh, information about their use of the game. But each item in this table, there is one item per user per game that they played. Because the number of users is very high, then that would be the user ID might be a suitable partition key because it has a very diverse range of values. And let's say for simplicity's sake that the games are just numbered 1, 2, 3, 4, right? Yeah. Um, so some users won't have played all the games, but that's all right. Okay. Just a visual representation. This is the kind of boring customer orders. That's the one I found. I just stuck with it. So, so this table, so I want a table that stores customer orders. Now, like as with any database, you have choices to make. Here, when it's DynamoDB, the choice is about what primary key am I going to have for this table? Uh, and the answer to that question actually depends on what are the nature of the queries that you will be executing against the table. And I'll talk a bit more about that a little bit later on. But let's supposing I've decided I'm going to have a simple primary key for this customer orders table. And I'm going to use, what am I using? I'm using order ID as my primary key. And it's also the partition key. Although I still haven't explained what does partition key, what role does it play? Alternatively, I could design the exact same table to have a composite primary key, where the composition is using order ID. Is that what I'm doing here? Primary key. No, I've decided to make customer ID the partition key and order ID as the sort key. So this combination is my primary key. Now, what's this partition key thing all about? So what happens is, now did I say, or I should have said that DynamoDB was really designed for very large databases, right? Like hundreds of gigabytes. size of databases. That's really what it's aimed at. If you've got small database tables, then maybe you don't really need something as sophisticated as DynamoDB because there are other options. There are both serverless and sorry, there are relational options available to you as well. Relational database options, serverless relational database options available to you. Um, so, uh, but let's say the nature of our data is up in that hundreds of gigabytes size. What DynamoDB does is it partitions your table across a number of nodes, computers, right? So that's what we're showing here. Let's supposing currently this table is broken up into 4 partitions, and each partition is hosted on a separate server, DynamoDB server. And over here, let's say I want to write an item or add an item, or we say put an item into my table, and it's my customer order example. And I'm using the the composite primary key uh, here. So the partition key is customer ID is based on customer ID, and the sort key is based on order ID. But it's partition key that I'm particularly interested in. So when you send this request to DynamoDB, there's a particular component within DynamoDB called what's it called there? The request router. Doesn't really matter. Okay, it's a component within the DynamoDB service. This is part of the service. And what it does is it takes the partition key value, puts that through an algorithm, and the algorithm determines which of the partitions the item should be written to. And as your table grows over time, more partitions are added, and the data is actually kind of reorganized as new partitions are added. But you don't have to worry about all of that. DynamoDB takes care of this. Note here now, um, this is my entire table, right? So let's say my entire table is comprised of 4 partitions. There's also a replication of this. These 4 partitions are replicated across 3 AZ zones. We said that a few slides back. But that's going on as well as the partitioning. The replication is all happening behind the scenes. But let's not worry about the replication. It's just the partitioning we're interested in right now. Similarly, like if I want to get an item, read an item from the table, well, always when we try to do a read from a table, we have to specify the primary key, the unique identifier. In this case, it's going to be customer ID, order ID. And again, this component, the router, it takes the partition key, which is, okay, it's customer ID, puts that through the algorithm, and that tells it which of the partitions should it send the request to retrieve the item. So each of these partitions is actually going to have some part of the DynamoDB service running on it, and it'll take care of retrieving the particular item. So this partition key value is central to how DynamoDB works behind the scenes. And if you choose a bad partition key, then you're kind of messing up this whole process. We said that the partition key should have a diverse range of values. What you don't want happening is all of the data going to one partition, or let's say all of the queries being associated with one partition, because then the other partitions are kind of slightly more redundant. So that's what this partition key part of the primary key, that's the role that it plays. We don't need to worry too much about it. We're not going to get heavy into database design, but you do need to be aware of just the significance of this partition key. Back to the world of CDK. How do I create my DynamoDB database? And the first thing to say is you don't create a database, you just create a table. That's classic kind of serverless level of abstraction. So that's what I'm showing you. Is that what I'm showing you over here? Yeah. Okay, so this is an extract from my stack file. So this thing here is another L2 construct, yeah. And as with all of my L2 construct, I have to tell it what uh, what is the scope of this construct, which is always the current stack. What name do I want to give this construct? That's completely arbitrary. And then the configuration, in this case, it's the configuration of a DynamoDB table. There are lots of properties available to us. We're only seeing a small subset of them here. Uh, I've included billing mode, but really we don't ever need to worry about what are the different options and all of that kind of stuff. There is a default value for billing mode, which is this one here. But let's not get into what are the different modes and what is the advantages and disadvantages of each. Uh, we don't have time for that, unfortunately. What you do need to specify, as I already said, is you do need to tell DynamoDB what's the partition key for this table in terms of the attribute name and its type. Uh, the removal policy is kind of useful. Like if, in our case, when we destroy a stack, we'll want to destroy the table as well. And so that's why I'm setting the removal policy to be this. Now, in a production environment, you more than likely would not want to do that. You'd want to retain the table. So there's a different value for the removal policy. But for our case, it's always going to be this, remove the table when I destroy the stack. And this is just the name for the table within DynamoDB. This is the name of the construct, which is slightly different. This is the name of the table. So it's as simple as that, right? And when I run CDK deploy, then if we go into the DynamoDB service and poke around, that's what I'm showing you here. We'll see our table created. Okay. DynamoDB, like every other service, has an API interface, and that API comes with an SDK. And so if you want to talk to a DynamoDB, and we will have lots of examples of, in our case, we'll have a Lambda talking to DynamoDB, but you could have a desktop application wanting to talk to DynamoDB as well. And so, surprise, surprise, you need to use the DynamoDB SDK in order to talk to the DynamoDB service. Alternatively, you can send raw HTTP requests, but we're certainly not doing that. Now, what I'm just documenting here is that so the SDK provides a number of classes in the object-oriented sense that we can use. I think there are about three actually. Yeah, I'm just classes that you can use uh, to communicate with the DynamoDB service. And they are specifically, there's a class called DynamoDB client, DynamoDB stream, and DynamoDB document client. Client is kind of the lowest level one. Um, this is the one that you would use if you were processing DynamoDB streams, which we'll talk about at the end of this module. The two ones that are important to us are this one and this one. And it turns out that really this is kind of the native client, the low-level client. This is a slightly more high-level and also easier to use client. Although if we looked at the internals of this client's code, it actually uses this internally. So this is kind of making the native calls, this DynamoDB client. It's making the kind of native HTTP calls across the network to the service. Now, clearly, we don't want to be bothering with all of that. So by us using the DynamoDB document client, we'll be making more traditional method calls and let the DynamoDB client take care of the low level stuff. All I'm showing you here is an excerpt from the package.json. And what I'm trying to get across here is that the SDK, the DynamoDB SDK, because it's quite large, it's broken up into a number of separate NPM packages. And you'll see that as well, but I'm just kind of confirming it here. Um, let's see. Okay, let's go back to. I just switch to a different branch here. So in this project, I have, here's my stack, and I have a table that stores movies, Maria, movie data. And I'm gonna skip over that. I've got a Lambda function that's going to be talking to DynamoDB. It's going to be getting movie items from the movies table. And that's about all that's going on. I've got a URL for that Lambda function, and I'm just outputting. Oh yeah, here's how simple it is in code in CDK world. This is how simple it is to declare what access rights my Lambda function has um, to the table. But of course, this single line of code gets translated into an IAM policy, a custom IAM policy, and attached to my Lambda function. And we'll see that when we deploy it. There is nothing else in the Lambda function itself, which we look at, you know, has a bit more code in it than before. But before we look at the code, so it turns out that, you see, you need to remember now that DynamoDB doesn't support anything as sophisticated as SQL. You remember SQL for querying relational databases. It doesn't have anything like that. It's far more restrictive in terms of the types of uh, queries in particular that you can perform against a table. And as we'll see, you can only query on the basis of the primary key. But for now, anyway, we're seeing here that there are only three different types of operations or interactions that you can carry out against a DynamoDB table. There are what are called single item requests. That's essentially kind of CRUD requests. So there's the put item request, which adds an item, sorry, to a table. This retrieves, reads an item from a table where you specify the full primary key, updates an item, deletes an item. That's straightforward enough. The second category of operation is called the query. And I'm saying this reads a range of items. Now, queries can only be performed against a table that has a composite primary key. If you cannot perform a query against a table that has a simple primary key. Like if we go back to the customer orders, for example, you cannot ask DynamoDB to retrieve all orders that have a certain total value less than 100 euro. Instead, what you've got to do is you've got to actually read all of the orders and process them on the client side to pick out the ones that have a total quantity less than 100 euro. And that's an illustration of how restrictive DynamoDB is terms of the types of queries that you can run against it. And it also means that you have to choose your primary keys, in particular the composite primary keys, wisely. But for now, anyway, okay. Queries allow you to read a range of items. Range here kind of refers to the sort key part of a composite primary key. In fact, I kind of say here, first of all, right, these are only suitable for tables with composite primary keys. It's stronger than suitable, really. It only applies to tables with composite primary keys. When you want to run a query against a composite primary key, you must specify the partition key, and then you optionally can tell it something about the sort key. You can specify an exact value for the sort key, or you could specify some sort of range of values for the sort key. Uh, Query results are always from now because of this restriction here, right? It really means that queries are always going to be the result for a query will always come from one partition within your overall table set of partitions. Because the query is specifying the exact value for the partition key. Now, that partition key value is going to map to one partition, one physical partition. And we know that all of the items that have that partition key, because there are going to be more than one item, because our primary key is a composite primary key, all of the items within that item collection have the same partition key. Therefore, they're going to be physically on the same partition node, which is what I'm saying here. They always come from the same partition, physical partition. So that's queries, right? The third type of operation is the least efficient, is what's called a scan operation. And a scan operation is where effectively you're asking DynamoDB, give me all of the items in a particular table. So potentially it has to go to all of the partitions to retrieve those items. So it sounds terribly restrictive, and it is, but that's the world you have to live in DynamoDB. In terms of designing your DynamoDB tables, as I've kind of already alluded to, the real thing you have to think about is your composite primary keys. And it turns out that you can have more than one composite primary key for a table. You can have, in fact, you can have 5 composite primary keys. How do we talk to DynamoDB from within our Lambda? That's what I'm showing you here. And these are just excerpts from the Lambda. So here is where this is kind of, let's see now. What am I doing here? Oh, oh yeah. This is initialization code. This is where we're establishing a connection with our DynamoDB table. And you can see I'm creating an instance of my DynamoDB client. That's the kind of low-level client. And then what I'm doing here is I want to create an instance of the DynamoDB document client, which is a kind of a wrapper for the first one. That's what I'm doing in this line here, because I'm actually passing it a reference to the DynamoDB client that I've created up here. And when you want to create an instance of your document client, let's give it a short name. When you want to create an instance of your document client, you've got to tell it, well, what's the native client that this document client should be using, and what's the nature of the marshalling and unmarshalling that the document client needs to perform. Marshalling and unmarshalling is explained down here. Like, we are writing TypeScript code here, obviously, and we'd like to be able to treat the items that we retrieve from a table, we like to treat them as JavaScript objects. Uh, but those data types that pertain to the JavaScript world, they are different from the data types that are native to DynamoDB itself. And I documented DynamoDB's native data types a few slides back. So we've got to kind of convert between those two data type schemas. And that's referred to as marshalling and unmarshalling. Now, uh, you can relax because this document client will do all of that for us, but we do have to tell it what type of marshalling and unmarshalling to perform. It's boilerplate code, as you'll see, but that's the explanation of this configuration here. So I have my connection. This is another excerpt from the same Lambda. These two bits of code now would not tend to appear straight after each other because this code is part of the initialization section of my Lambda function, whereas this code here would be within the handler or the body of the function itself. But this is how we actually talk to DynamoDB. And it's based on a design pattern called the command pattern. So, of course, we're preceding it with an await because we're talking across the network. This is a reference to my document client that I've established up here. And there's really only one method that you invoke called the send method. So whether you want to do a read or a write or a delete or an update or a query, we do it all through this send method. And the send method takes one argument, which is an object. And we refer to the objects as command objects. And in this case, and there is a set of valid command objects that we can send, if you like. And we'll come across most of them. I mean, it's small enough said really. There's only a get, a delete, an update, and a query. I think there's probably only 4. This looks like it's a get command, and a get command really means that we want to read one item from our table, and we have to specify the primary key of that item, which is what we're doing here. And it's our movies table from a slide or two back, and our movies table had a simple primary key, and the attribute was movie ID, so that's that there. And we also have to tell it about what table, because we don't specify a table up here at all. Here we're just establishing a connection with the DynamoDB service. It's in the individual commands that you specify the table. Process.env there is, I'll explain that later on, but that's going to evaluate to the table name. So if I now look at my code actually, so this is my stack file, and am I looking at the right code? Okay, here's my table. No, that's not my table. Sorry. Here's my table. Get it right eventually. Here's my table. Here's my Lambda function. And the only thing that's new is this bit here. You can pass environment variables into your Lambda function. And because my Lambda function is going to be talking to my DynamoDB table, that's why I'm passing in the table name. This can be anything you want. You can call the environment variable anything you want to. And if you had 3 or 4 tables, you'd have an environment variable for each one of them, assuming that the Lambda needs to talk to each of those tables. I also am passing in the region because when we configure our DynamoDB client, we do have to tell it what region our table is in. So that's okay. And then the Lambda itself is this one. There are other ones as well. We'll come across those later on. Here's my Lambda function. And I've just created a local private function called that, which is down here at the bottom. Where is it? There it is there, right? So that's just making the connection with the DynamoDB. I mean, I could, just more slightly better to put it into a private function. So I'm calling the private function there. Here's the body of my Lambda. And let's actually, so my Lambda, sorry, no, my Lambda also has a URL. I'm generating a URL for it. Somewhere. Thought I was. Oh yeah, sorry, that's where I'm generating a URL for my Lambda. And so I've already deployed this. And my intention is to trigger my Lambda from the URL and include a movie ID as a query string parameter. I've just decided that arbitrarily. Okay, so I've already deployed it as I said. And if I switch over to DynamoDB, sorry, over to Lambda service. Just watching my clock now, I'm running out of time. And here is the Lambda. Sorry, this is the Lambda here. There is a second one that I'll explain the next day. I go into that and find the URL. Now this isn't going to work, but let's just do it anyway. So I said that I want to be able to pass a movie ID as a query string. And clearly my Lambda function needs to check, well, was there any query string included? And it looks like there wasn't, we can see up here. And so I'm getting an error message back, but I've programmed that error message. So if I just grab this URL, I could do it from here, but it's slightly easier to do it from Postman. Go back into Postman, and I've arranged or I've prepared this already. So if I go up to this collection and set the variable. Don't worry about this one. So that's the URL and that's my variable. And if I go into this request, so I'm sending a get, I want to send a get request to that URL, and I've tagged on my query string. Now again, I've decided that the query string key should be movie ID and the value should be movie ID itself, a valid one. And if I click send, do I get anything back? Looks like I get some data back, all right. And here are the attributes of my movie. Where did that come from? Well, part of my as part of my stack, I want to seed the database. Now I've put my seeding data in here. This is my seeding data. And seeding the database is kind of an edge case, really, but the seeding is actually done by this code here. And I don't have time to explain it now, really, or maybe I have a couple of minutes, but you can create what's called, this is specific now to the CDK framework. You can create what's called a custom resource, right? In our case, we want our custom resource. Uh, a custom resource instance will always create a Lambda function. And what that Lambda function does depends on how you kind of configure the custom resource here. Now, I want my custom resource to, um, first of all, I want it to run only when the stack is created. I want the custom resource Lambda to seed my database. And that's only something you'd want to do once. You don't want to keep reseeding your database every time you redeploy the stack. Make changes and redeploy it. So I've configured it to only run on the creation of the stack. A lot of this is boilerplate, but essentially what the rest of this is saying down here, all of this code, and there is quite a lot of it admittedly, but what it's kind of saying is it's telling the Lambda service to put code into the Lambda function. It actually dynamically creates the code for the Lambda function, which is kind of neat, really. And the code takes care of the seeding. Now, I've actually written the code over here, and I tell it where this code is in the configuration over here. And essentially, it takes care of dynamically creating the Lambda function, putting the code into that Lambda function that I've defined here. And what that code does is, as I said, it reads all of the seed data, picks up all the seed data, and writes it as a batch of items into my table. Uh, and if I go back to AWS, go into the Lambda service, you see this Lambda and this Lambda, those two are from this stack that I've deployed. But I've only written one explicitly, and I've only written one Lambda function. But how comes there's two Lambda functions? Well, the second Lambda is the Lambda that was dynamically generated by that custom resource. As I said, it's kind of an edge case. You will not be writing any custom resources other than the one that I'm showing you here. And so you can just cut and paste it. And that's really what's kind of going on behind the scenes. If I switch over to DynamoDB and we leave it at that, and I go to tables, and there's my movies table. And if I have a look inside it, here's the actual movies that my seeding data that I've put into the table. Okay, I have some more explaining to do for this stack because I do want to just step through the Lambda function itself. Though a lot of it should be easy enough to understand. Maybe you can look through it yourselves. And you do this in the lab anyway. I think you replicate this stack in the lab and add to it a little bit. Yeah, I know I've got a couple of minutes left, but I'm not going to continue on. I prefer to maybe start afresh the next day, and you'll have worked through the lab at that stage. So if I bring up the lab, So in this section here, you're just generating a URL for your simple Lambda. Here, you're creating a DynamoDB table. Here, you're writing a Lambda that talks to DynamoDB. And there's a little bit on debugging with CloudWatch there. That's fine. There's an exercise. You might be able to handle the exercise. The exercise gets you to write a second Lambda that, what does it do? I think it just reads all of the items, all of the movies from the table. So using the scan command rather than the get command. You won't be able to do this section here really. So you should be able to get as far as maybe the exercise, but certainly because all of this stuff is just prescriptive, right? But like everything, you need to try and understand it as you work your way through it. Okay, I'm done for today, I think. Or maybe there is a question or two from you. No. Right, I'll touch base with you in next week's labs. Thanks for that.